Hi everyone, welcome back to my channel. This is my second video in which I'll be showing you how using electromagnetic induction power can be transferred wirelessly. I'll be using zero voltage switching drivers, it's also called as ZVS drivers, to achieve this. Before discussing about wireless power transfer, let's see why we require wireless power transfer. So what I'm showing you is a picture of our undergraduate project called Electromagnetic Induction Based Roads with a short form EMIR. So we constructed around 10-meter long prototype road for transferring approximately 100 VA power to charge the battery of prototype electric vehicle. So that was the objective of this undergraduate project work. And we have used a toy car which requires around 50 to 100 watt power. So that's what we have used. And the entire project work I will explain you in the next video. I'll make a separate video, and only the one part of this that we will see today, that's the wireless power transfer part. And in my first video I discussed about UHF RFID reader, so that is also used for this project work. As you can see, there is a prototype toll gate, and inside this toll gate you will find UHF RFID reader, and the vehicle has a tag. So even with the distance of 5 meter, so RFID reader is able to detect. So that was the purpose. And this entire project is solar powered. Let's discuss that in the next video. But in this video, we'll focus on the wireless power transfer. And this project is funded by Expo Live, Dubai, under University Innovation Program. And these are the team members. And we have won several awards. We have taken part in different competitions and we have won awards. And so this is important for today's video. And you can see that the wireless power transfer, you have a primary coil which is placed on the road, prototype road, and similarly the secondary coil is in the on the vehicle. Okay, so the power will be transferred through electromagnetic induction. This video shows the testing phase of wireless power transfer. We initially tested with the pancake coil. We have wound the leads wires in the form of a pancake coil, and as you can see, even with the 6-inch spacing, we are able to light a 25 watt lamp. And so ZVS driver has been used here for testing. So this is the overall block diagram of wireless power transfer. So you have a core component called as ZVS, zero voltage switching driver, which acts as an inverter, and it requires a DC voltage. So you can have a power supply from which 12 volt can be fed. But for our project, we have used solar energy. So solar panels are there. From solar panels through charge controller, we give the supply voltage to ZVS, and then the ZVS. If you look at ZVS, it has got a input which is DC and output which is AC, and there is an internal capacitor. So you require to connect a coil or an inductor externally. So we used a primary coil. As you can see here, this is the primary coil that we have used that's directly connected to output of this. And to tune the frequency, we had to use an additional capacitance. So we used a capacitor bank. By increasing this, by connecting these capacitors in parallel, the capacitance value can be increased. And since these capacitors are working at very high frequency, so we can go for MKS capacitors rather than conventional capacitors. So that is one thing. That's about the primary part. So this is the primary coil, which we call it as a transmitter coil. And similarly, on the other side, you have the receiver coil. The receiver coil or the secondary coil, which is placed in the chassis of the vehicle. So that also requires a capacitor bank. Though I have not shown here, the similar capacitor bank will be available, and the frequency has to match LC. There's a formula 1 by 2 pi root LC. So only at resonance the maximum power will be transferred from primary to secondary. So that is there. And if you require DC, then you can use a rectifier. So we have used a rectifier. Bridge rectifier has been used here, and we did not have high current rating diodes. So we connected 1 ampere diodes in parallel, so that increases the current capacity of the diodes. We rectified it, then we filtered to remove the AC component or ripple. So that's how this is the entire block diagram. That's how it. So ZVS is the core component, and readily you can purchase this. But only thing is the design of this coil that's important for maximum power. You need to design it properly. We'll have to refer to some literatures. So what should be the perfect dimension of this coil? This is important, and we haven't used ordinary coils. We used Litz wires. So Litz has a multiple strands, that reduces the skin effect. So we'll discuss about these special wires separately in another video. When we are discussing about the complete project, we'll discuss about these videos. So thank you so much.